Squares with sides of length x are cut out of each corner of a rectangular piece of cardboard measuring 47 feet by 25 feet. The resulting piece of cardboard is then folded into a box without a lid. Find the volume of the largest box that can be formed this way. And we'll get to B after we do A. Okay, so we've got this flat piece of cardboard here, and it looks to be rectangular, and we are cutting out little squares of this thing so that it can fold into a box. Okay, and the squares are length x. So this is x and this is x. Okay, so x by x. Okay, so we need to figure out what the volume of this is going to be once that x gets folded up. Okay, so the volume of a box is length times width times height. Okay, so length times width times height. Okay, so the length and the width we'll say are the base, and the height we'll say is the x. Okay, so we can say that, let's just go ahead and put the x out front because we know it's going to get folded up. Okay, so that's the height. And then the length, it doesn't matter length or width, which one we say. But if you look at this, it's 25 minus what? Well, we're going to chop off this x and this x right here. So it's 25 minus 2 of whatever the x is. So 25 minus 2x. And likewise, this side here, we've got 47 minus this x and minus this x. So the width of it is 47 minus 2x. Okay, let's clean that up a little bit. Let's multiply that out and get it cleaned up to make it easier down the road. So if we multiply this through, we should get, let's see, I think I have 4x cubed minus 144x squared plus 1175x. I'm not going to work that out. You can multiply that through yourself and confirm that that is actually what we get. So let's go ahead and take the derivative because we are trying to find the maximum volume. So we're trying to maximize the volume, which means we need a derivative. So v prime, or dv over dx, but I'll write v prime, is equal to 12x squared minus 288x plus 1175. Okay, so that gives us our derivative equation. Now, to find the critical numbers where the minimums and maximums may occur, you need to set that equal to 0. So we're going to have 12x squared minus 288x plus 1175 equals 0. Now, you could try to factor that, but you're probably not going to have too much luck. You could try to reduce that, but 1175 is only divisible by 5 and 47, I believe. So it's not going to reduce. So we're just going to have to use there's two methods of solving this. You can use the calculator and graph, or you can use the quadratic formula. Some of my videos that I've made, I graph, and on others, I use the quadratic formula. So in this one, I'll use the quadratic formula. So it would be negative b. So here's our b. Remember, this is a, b, and c. So the quadratic formula, in case you forgot, negative b plus or minus the square root, b squared minus 4ac, all over 2a, and that gives you your solutions for x. Okay, so we get negative b, but it's already negative, so 288, right over here, 288 plus or minus the square root of negative 288 squared minus 4 times 12 times 1175, all divided by 2a. A is 12, so let's just put 24. Okay. So that should give us our solutions. We can type it into the calculator just like that. So let's open a parentheses because we do have a numerator and a denominator. So this will be around the entire numerator, 288. First I'll do plus the square root of, let's see, negative 288 squared. We could write the negative if we want, but we know it's going to be positive anyway. So I'll just put 288 squared minus 4 times 12 times 1175. Close parentheses around the square root, close parentheses around the numerator, divide by 24. Okay, so we get one solution. X is approximately equal to, I say approximately because it's an irrational number there, but it is 18.4 let's say 7, 9. Okay, now the nice part about doing this is I can hit second enter and it'll pop up the whole thing again, and I can just go change this to a minus sign and hit enter again, and I get the other solution. X is approximately equal to 5.21. Okay, so we get two possible solutions where the critical numbers are and where we might find a maximum volume here. So let's look at those critical numbers in terms of the problem itself. Now, what is our interval of interest here? In other words, what could the x values possibly be? We know that it can't be negative, right? You can't cut a negative slice out of a box there. So x has to be at least 0. So we'll say our interval of interest starts at 0. And where does it stop? What's the biggest x value that we could have? Okay, well, if you remember, you're cutting out an x on either side. So looking at the smaller of the two sides, which is the 25 here, what's the biggest x value that you could cut out such that you can cut an x value on one side and the other? Well, if you cut it right in the middle, right, if you cut it right here, then you would split the box directly in half. Anything more than that, and you couldn't get an x and an x on both sides. Okay, so the biggest cut that you could possibly make would be right here in the middle, which would make this whole side x and this whole side x, which means that each one of those x values would have to be half of 25. Okay, so 12.5. You could do the same thing for the 47. You could say, okay, well, it's can only be here, but the 47 is much bigger than 25, so that x value would be much larger. So it's restricted by the smaller side, and you can't fold it any more than half of the smaller side. Okay, so x cannot be larger than half of 25, so we will go to 12.5. That'll be our interval of interest. The reason that's very important in this problem is because if we look at our interval of interest and we say, okay, well, 12.5 is the biggest that x can be, but we have this that says x is 18.79, well, we're just going to do that because it's not inside of our interval of interest. The problem itself doesn't make, or the answer itself doesn't make any sense. Okay, so we get an answer, our sole answer is 5.21. Okay, and then we can plug that into the problem, into the original formula, which was right here. You can't see it right there. And see what that maximum volume is. So V is equal to 5.21 times 25 minus 2 times 5.21 times 47 minus 2 times 5.21. Okay, so let's plug that into our calculator there. I do it this way. I'm going to type 5.21 and hit enter, and then I get to use the answer instead of typing it in every time. You don't have to do it this way, but this is one way of doing it. So I get the answer, that's second with the negative sign, times 25 minus 2 times the answer. Let's put parentheses around that. Sorry about that. And another parentheses, and we have 47 minus 2 times the answer. Okay, so you get a volume of 2,778.7. Okay, and let's see, that's feet cubed. Okay, so that takes care of A. That is your maximum volume given those restrictions. Now let's go back up to B. B says, suppose that in part A, the original piece of cardboard is a square with side lengths S. Find the volume of the largest box that can be formed this way. So if it's a square, let's make a square here. We're still going to cut the sides out, but they're saying that this side is S, and they're saying that this side is also S. So no numbers, but we know it's a square base. Okay, so looking at length times width times height of this box, okay, remember that we are cutting out, so the one side would be, well, both of these sides would be the same, but it would be S minus 2x. So the volume is going to be the x, that's the height, and then S minus 2x. This may look like a 5, but it's not a 5, it's an S. S minus 2x again. Okay, so let's go ahead and distribute that out. So v is equal to, I'm going to leave the x out here for the first step. So we'll have s squared. These two middle terms, it's negative 2sx and another negative 2sx, so negative 4sx. And then the last one is plus 4x squared. Distribute through your x, and you get s squared x minus 4sx squared plus 4x cubed. Okay, so just like last time, we have our volume formula here. We're going to take the derivative of that. Remember, s is not a variable. This is not the variable we're working with. X is still the variable. S is just some number. We don't know what the number is, but it's just some number that makes this a square box. Okay, so this is a constant, this is a constant. So we treat them as such. So the derivative of x with the constant out front is just the constant. Bring down the 2 here, so that makes negative 8sx. And then bring down the 3 plus 12x squared. Set that equal to 0, so 12x squared minus 8sx plus s squared equals 0. Okay, and we'll do it the same way as we did last time with the quadratic formula. Okay, remember this is a constant and this is a constant, so a is equal to 12, b is equal to negative 8s, and c is equal to s squared. Okay, so let's use the quadratic formula. X is equal to negative b, it's already negative, so 8s plus or minus the square root of b squared, so negative 8s squared, minus 4 times a, which is 12, times c, which is s squared, all over 2a, which is 24. Clean that up, you get sx, or 8s plus or minus the square root of, let's see, that's positive 64s squared. And this one is negative 48s squared over 24. If you combine like terms on the inside here, that is a minus. So you get 64 minus 48, that is 16. So you get 8s plus or minus the square root of 16s squared over 24. If you go ahead and take that square root, you get 8s plus or minus 4s over 24. So that's two solutions. Do the addition, and it's 12s over 24, which is s over 2. And do the subtraction, and it is 4s over 24, 4s over 24, which gives you s over 6. Okay, so now that we have these two solutions, let's look back in the original volume and see what those solutions do for us. So if we plug, let's try the s over 2. So we plug that one in, we get x times, I'm sorry, not x. You get v is equal to s over 2, plugging in for x, times s minus 2 times s over 2, and then s minus 2 times s over 2. Okay, I'm plugging the s over 2 in place of x in that equation right there. Okay, you'll notice that this cancels right here and you get s minus s, so this whole thing turns into a 0. Both this and this are 0 terms. Okay, so you get volume of 0, so that doesn't maximize anything, right? You got no volume there. Okay, so the other one, this one's gone. The other one is what we're going to use for our critical number. And s over 6, we could plug that in. V is equal to s over 6 times s minus 2 times s over 6 times s minus 2 times s over 6. Those are s's, not 5's. Okay. Let's see, we multiply that through, so what does this become? This is negative 2 to 6, so this becomes s over 3. So s minus s over 3, and this is also s minus s over 3. S minus s over 3 squared. This is 1, and this is minus 1/3, so it's 2/3, right? So 2/3 s. So s over 6 times 2/3 s squared. Okay, multiply that through. The s gets squared and goes with that s, so that's s cubed. The 2 gets squared, so that's 4. And then the 3 gets squared, that's 9 times 6 is 54, which reduces to 2s cubed over 27. And that would give you your maximum volume if you had a square side.